The second question might be a bit confusing. So I didn't mean to use the letter, but just merge the two data frame using number, but follow the order of the second data frame. Okay. This is pd.merge. Okay, how do we do the first one? Okay, merge the two data frame using numbers, which is this column, and we don't want any NA value. Okay, let's have a look at the two data frame. So my first data frame is called numbers. Okay, my second data frame is called words. Okay, if I want to merge the two data frame, I need to find the common key. Okay, the common key is this column, number. Okay, and I don't want any NA value, so I want an inner join. So how can I merge the two data frame? Again, we have to use pandas pd, and we have to merge, and then we put the two data frame inside, number and words, and because we have a common key called number, sorry. Okay, so we can just do it right away. Because for pandas, the merge function has a default value for inner. So if you don't specify anything, it's going to be an inner join. Okay. Any questions for this one? Okay. The second questions. Well, I made a typo in here. This should be a number. Okay, but we want to use the index from the word data frame. So basically, I want to reserve this order. And actually, you don't have to do anything to reserve the order. But let's say if this order is something specific, you can do it by how equals left. Okay, and put the word data frame. Right there. Okay, then after you put how equals left, then you're sure that everything goes into the order of words. Okay. Alright, any questions for this? Okay, later on we'll explore a real dataset called a Boston house price dataset. Okay, this dataset is just the house price for the American city, Boston. And by execute the code, you can have a look at the datasets. Okay, this is a pretty large dataset. You can have a look. Okay, so it has a lot of columns, and if you want to know the full shape of it, you can do dot shape, and then there's 500 rows and 14 columns. And if you wonder what the column means, here are some explanations. So we have some basic information about the house price. So we have the crime rate, like how many crime is there in a town. You have the like the property of the zone, the average age of the house, the average number of the room, etc. Okay, so it's just some basic statistics for your house. Okay, so let's say you don't know anything about the datasets. The first standardized approach is to find shape, which I just did. And this gives you a rough idea of what you're dealing with. Okay, and after that, you can check the data type. To do this, you just do dot d type. Okay, dot d type. And you can see a lot of float 64 right here. It means everything is just number, and it's very easy to manage. Okay, after that, you have to take a first look at the datasets. You look at it by dot head, and just have a glance through. So you can see, okay, this is obviously the age, and then you have the price right there, and you have the crime rate. Okay, nice and simple. Okay, what's the next thing we want to do? Because everything is number, we can try to find the basic statistics of all the numbers. Okay, if you do it in Excel, you probably have to do it row by row, line by line. But right there, you just do dot describe, and you have all the basic statistics for every row. Okay, this is quite handy. So crime rate, we have the mean of 3, the average age is 68, and then look at the price. The max is 500, and the mean is 22. We don't know the unit, but this should be million, I guess. Okay, but this doesn't tell us a lot of information, and we have to visualize it. Okay, but before we visualize, we have to know, is there any missing value? And to find the missing value, we learned is no, right? This is just a different way to write it, but you can do df.isNo. Okay, try to find the sum. Okay, that's how you find it. So now it just lists out for every column, is there any missing value? So we are very lucky there isn't any missing value. Okay, so we can plot it right away. Okay, the first thing we should be curious is the correlations. Everyone knows what's the correlations? Okay, correlations just means how one variable affect the other one. If it's 1, that means totally correlation. So the two variables move along the same way. If it's -1, that means they are opposite. Okay, 0 means they don't have any correlations. Okay, so if you do df.core, you got a matrix like this. So just do .corr. Okay, you can see a diagonal is 1 because you're comparing with yourself. Okay, but if you don't look at the diagonal, find something that should interest you. So the crime rate is negatively correlated with the price. So that makes sense because no one wants crime. Okay. And then we have the number of room and price is positively correlated. So it means the more number of room, the more is the price. And we also have like age is negatively correlated, which makes sense. Okay. So this is just a quick overview. But again, this doesn't look very user-friendly. And we want something more fancy. So, okay, I'll scroll it down to show you what a correlation matrix can be done. So you can do it this way. This way, it's way more friendly. So everything red is positive, everything blue is negative. And this way you can have a very quick glance on what's important to your price. Okay, obviously, tax is negatively correlated to price, and then you have all the other stuff. Okay, let's go back to our correlation table. And let's try to do some visualizations. Okay, if we want to plot something in Python, we always have to input a library. And the library we need is called matplotlib. Just do matplotlib.pyplot. Okay, as plt. Okay, just stick with plt and you'll be fine. Okay, the first thing we want to plot is the scatter plot. Okay, probably we don't want to plot it against the index. We should find something more interesting. So let's say I plot it across crime. Okay. What the first line does is I assign the crime column to X and the price column to Y. Okay. And the next line is just tell Python I want to plot a scatter plot. So I just do using the matplotlib library, plot a scatter plot with parameter X and Y. Okay. If you're lazy, you can actually do it this way. And scatter and then df.crime, df.price. Okay, if you're lazy, you can do it this way. And just do .show. And then you can start to have your first visualizations. So your x-axis will be your crime, and your y-axis will be your price. Actually, that's a bit weird. I probably should change the order. So price and crime. Oops, sorry. Okay, what can you tell me about the graph? Price and crime.
Lower the crime, higher the price.
Yeah, the lower the price, the higher the crime. That makes sense, right? And okay, probably that's everything you can tell me. And probably I don't think there's anything more here. Okay, the other thing you want to plot out is price. Okay, I want to plot out the distribution for the price. And if you're dealing with two variables, you can plot a scatter plot. But if you're dealing with one variable, because you don't have anything to plot against, the only thing you can plot is against yourself. Okay, and if you do a histogram, that means how the price is distributed. So you just do okay, you can ignore the first line and just do plt.hist and then df price. For a number of bins, the more bins you apply, the better the graph, but the slower is the process. Okay, and what can you tell me about the histogram? Any clue? Okay, so this tells us the whole thing is quite normally distributed, but it has a very long tail. Okay, these long tails are the expensive flag. Okay, it means a lot of people have houses in this range, but you know the very rich guys are right there, and we have less of them. And you can see in here we have a very tall tail right there. And what I guess is every houses that exceeded 50 millions will be marked as 50 millions. So this should be a very long tail, but they just sum everything and put it right there. Okay. And if you want to plot different histogram, that would be crime. Okay, and what does this graph tell us for a crime? Any clue? Yeah, a lot of places are quite safe. Okay, but some of the places has close to 100% crime. Okay, I don't even know what that means, 100%. But like some of the places are very dangerous. Okay. And you have text. Okay, again, I think it won't be surprising that the two graphs looks quite similar, tax and house price. You know, probably the more expensive your flat is, the higher is the tax. And so the two graphs looks the same. And you probably can say the price and tax is heavily correlated. Okay. Another exercise for you, a quick one. Yeah, try to plot out age as a variable. Try to plot a histogram. Okay, are you done? Okay, that's how you do it. Because we have one variable, you have to plot a histogram. Okay, I do it step by step. First step, the library, PLT. Second step, histogram. Third step, what's the variable you want to plot, which is age. And if you don't understand why do I do df.age, it's because this is our data. And you have to have a list to plot on a histogram. Okay, last step, second last step, specify the number of bins. Okay, if you plot it now, it won't show anything. You have to put plot show. That's one annoying part for plotting, but that's how it looks like. What can you tell me about the graph?
Most of the houses are old.
Yeah, a lot of houses are old. If you compare it with the price histogram, the shape doesn't look the same. Okay, but probably you start to have a feeling that the older house has the peak like the cheaper houses. So probably they are negatively correlated. Like the older the houses, the cheaper the prices. Okay. Okay, just another example for plotting crime and price, which we already did. Okay, probably I'll do this for you. Just the next exercise is just plot price with age. So just do change the variable with age. Okay, probably doesn't make a lot of sense. I think for standard practice, always put the base variable on the x-axis. Okay. Okay, what can you tell me about the graph? This is price, and this is age.
There's a lot of buildings that are around 20 years old. The bottom is
So that's the age.
yeah, it's age.
That's price.
So it shows that the more younger, there's actually a lot of buildings that are old.
Yeah, a lot of buildings
And
that are old.
they never pass 25. Like many of them are under 25. About. Like a lot of buildings are normally under 25 years old.
Okay, yeah, that's a price. So you can say, okay, all the old houses are very cheap, except these guys. And there's a clear line right there. That means a lot of houses are under 25. And yeah, basically that's all the conclusion we can make. Okay, up to this point, we plot a lot of different graphs, and we have like some bits and pieces, and we don't have a very good overview of everything. And that's why we need our next plot, which is a very important plot, which is called the pair plot. Okay, this pair plot looks cool. Okay, and how do we use it and what it means? Is we are basically plotting a lot of graph at the same time. Okay, because we have a very huge data sets with a lot of columns. Okay, if you need to go into it one by one, it's going to cost you a lot of time. So one quick overview of every single variable is do a pair plot. Okay, if you want to understand what's a pair plot, look at the axis. So look at the y-axis. This is all the variables, and the x-axis is again all the variables. And if you look at the diagonal, it is just comparing with itself. Okay. Remember, every time you compare a variable with itself, it's gonna become a histogram. Okay. If you're comparing with a different variable, it becomes a scatter plot. Okay. So now we can have a very quick overview to see which two variable has some pattern. So in here you can see LSTAT and price is quite negatively correlated. And right there, I think it's the same variable. And then probably you can say these guys are quite positively correlated, which is LSTAT and NDX. Okay, and we have also tax. Where's tax? Tax and price. Okay. And if you're not familiar with correlations, basically look at the general directions of all the scatter plot. Right, this one is the most obvious one. As you can see, it's like a line with 45 degrees. Everything that is not in these directions, this is negatively correlated, and these guys are quite positively correlated, and this is quite positively correlated. Okay, so now you have sort of a general feeling of all the variables. And by looking at this, you can compare this graph with the correlation matrix, which is this one. Okay, we have price, tax, and remember, if you compare price with tax, in here you can see it's minus 0.47. And basically it's this graph. Remember I said everything on the reverse 45 degree is negatively correlated. And you can just prove it on the graph below. Okay? Okay, so to plot a C-bond, a pair plot, probably you have to do okay, just execute the line. Okay, the first line is just some styling setting, and in here I just control which columns I care about, because if you plot all the columns, this graph is going to be very big and it would take a very long time to generate. So I just took 5 of them, and in here you have a parameter to set the size. So basically the bigger it is, the bigger is every single tiny graph. Okay? But don't try to remember the syntax here. Just copy it every single time you need it. Okay, again for this correlation graph, again it's using a different package called C-bond. And again, don't try to remember all the syntax. For plotting graph in Python, no one actually remember the syntax. Everyone just copy them when you need it. Okay, so if this doesn't make sense, don't worry, you just need to know where to copy. Okay? And then okay, in here you can see there is a function that you never saw, np.coefficients. So it's just a way to do correlations with NumPy. And in here, there's some explanations of how to use it. Okay. Okay, let's go through this quickly. So another cool stuff to learn is something called a joint plot. Okay. Basically, a joint plot is a combination of histogram and scatter plot. Because scatter plot is comparing two variables. But remember, for every one variable, you can do a histogram. So a joint plot is just a histogram on top with a scatter plot below. Okay, so now you probably can visualize these guys. When you add up all these points together, it becomes this bin. Okay, and in here you have a very, very short bins. It's because you don't have a lot of points. Okay, and hopefully that helps you to visualize your histogram better. Okay. Okay, again, the question downward is just to plot price and age, and that's just change age. Okay, that's how you plot it. And probably you remember the shape for the age and the shape for your price, and that's how it comes to this histogram. Okay, you can do something cool. So you can change the kind, like what kind of graph you want to plot. You can plot something called a hexagram, I think. So everything will be like I don't know, like a hive. And the deeper the color, the more dense is the distributions. Okay. Or you can do it with like a heat map style. That's even cooler. Okay, but all you need to change is just the kind. Okay. Okay, another more practical datasets for anyone who want to get married, because this is a diamond datasets. Okay, so just try to run the code, and you can see this is our first quite big datasets. It has 53,000 rows. And if you see the data types, this time it's more complex. You have some numbers, but you also have some colors and clarity, which are not really a number. Okay, so for those who got married and have bought a ring before, you probably know these terms better. So for a diamond, you have this, I don't know how to pronounce it, carat. And you also have some cut, like how good is the cut, and what's the grading for the color, what's the clarity, okay, and what's the depth, okay. And for all the guys, probably you only care about the price. And this dataset is just like a nice buying guide for, okay, what are the fair price for the ring or for the diamond you need to buy. Okay, so let's drop the first column. And again, check for any missing value. It's a very clean dataset. Okay, let's try to think of it something more logical. The bigger the ring, the higher the price. And that proves our concepts. The bigger the ring, the higher the price. Okay. it doesn't work. Okay, just for now, just skip this Plotly. I'm not sure if it works on your computer. It works? Okay, so if it works, Plotly is a much better way to plot a graph. Not sure why it doesn't work on my computer.
Sure.
Sorry?
You know, sometimes when you import,
Yeah.
you have to write something that starts with the percent.
Oh yeah. Okay. Never mind. I forgot how to do it. Percent inline or something.
No, there is something before in
Yeah. Never mind. I'll try to search for it. Inline. Okay. Okay. Never mind. I'll show it without using the Plotly. So this is how you plot carat with price. Okay, what can you tell me with the graph? Okay, this is the price, and this is how heavy is the diamond. Okay, what is the conclusion you can make out of the graph? If you plot a straight line, you can see everything below the line is less than everything above the line. Okay, so that's mean for the same price, I can buy a ring with 1 carat, or I can buy a ring with 5 carat. Okay, that's mean everything above the line is way overpriced. Okay, and like obviously this is quite skewed, and if you buy rings in this area, it means you're paying too much. Okay, so something to avoid. And then also look at the histogram for the price. Okay, a lot of very cheap rings and very few expensive rings. And again, this is quite in line with the weight of the ring. And if you plot it against many different variables, carat, price, I forgot what X, Y, Z, but if we just looked at price and carat, now this is a quite obvious trend. Okay, it's very positively correlated. Okay, at this point you might wonder, why do we need to care about correlations? Any clue? Let's say now I don't want to just explore their sets, but I want to build a model. Okay, let's say I want to build a model to predict the best price or the fair price for the diamond. Then I need to know which variable to add into my model. Okay, although in data science you can basically add everything and let the computer to decide. But if you want to explain to someone, okay, why did I drop this variable? This is a better way to explain. Okay, because I drop it because it's not correlated. Okay, again, just a correlation graph. And you can see this is a highly positive correlations. It's like very red, the entire thing. And I have carat, price. I really forgot what XY said, but never mind. So this is just a joint plot for the price and carat. Same thing. Okay, the last thing I want to talk about is how to plot characters. Okay, because we have a lot of characters right there. We have a cut, we have color, and we have clarity. Okay, obviously these guys contribute to the price. One thing to do is convert it to number. You can plot a dictionary and just change all the cut to numbers. Okay, if you do value counts, you can have a quick overview of the distributions for for the cut, and then you can give a rating for every character. Like premium is 4, fair is 0. So you're just basically quantifying them, and to say, okay, good is better than fair, premium is better than good. Oops. Okay, and I think, yeah, I just replace cut with the numbers. Okay, now cut become numbers. Okay, and after that you can start plotting cut or adding cut into your I don't know, model or visualizations. Okay. Lastly, there is something called a box plot, which if you care about the distributions, this is like a 1 standard deviations apart. The one in the middle is the mean, and then you have the maximum and minimum. Okay, but box plot is not being used quite often. It's just something good to know. And if you have a lot of variables, you can do a massive box plot. Okay, and I think the only conclusion I can make is a lot of them has a very long tail. Okay, that means when the price goes up, it can go crazy. Okay, and okay, if you plot the density plots, it's very similar to a histogram, but just instead of discrete histogram, this is like continuous value. Okay. And lastly, if you scroll downwards, I'll probably just copy the code for this one. But this one is just how to show the density or the count with different classes. Okay, that means in here you have like a lot of different kind of colors, and then you can see the distributions of colors within every variables. Okay, or you can show it this way, but it's not very nice. Okay, it didn't work in here for some reason, but let's try again. Okay, if you can plot it on your own computer, try plot it again. In here, I try to show some more advanced, Plotly graph. Maybe it's actually better to show it in the Plotly websites. Okay, so this is the Plotly websites, and I strongly encourage you to learn visualization here, because one advantage for plotting things in Plotly is the graph is interactive. So if you hover around, it's going to show you the different statistics. Okay, and it's way more good looking, I think. And if you go, like, how do you arrive this page? It's just do Plotly and then Python, and then just go to Python graph library, Plotly, and you can see a lot of cool visualizations. And here you have all the basic charts, and here you have all the Seaborn style charts. And what I wanted to show you is actually these guys. So if you copy the code and just change some of the, I think if you want Plotly to work in your own notebook, you have to change the library names to plotly.offline, and everything works. Okay, it didn't show it properly again, but supposedly this will show you a very nice graph or map of America, just like this, and you can just hover around and see, you know, the place and the state of California with the populations. Okay, and all you need to do is just copy the entire code and just change the variables you want to change. Also, you can try to just copy the time series or copy the. They even have some 3D charts that you can just copy the code straight away. Okay. Okay, so okay, before we go, I want to talk a little bit about the presentations. So, do every one of you got a datasets? No?
Not yet.
Do you have any clue where to find datasets?
Yeah.
Okay, so this instruction is actually for the previous class, but this time I don't want to limit you. I think the only guide is try to find something big. Okay, try to find some big datasets. If you have your own interesting datasets, then that's the best. If not, then try to find it on Kaggle or find it right here. Okay, these are some links that leads to some interesting datasets. Okay. If you are confident, try to find something with missing data. If not, try to find something simple. Okay.
Is it possible for us to send you our data set to see if it works or not? Because I have
Yeah, sure.
some data, but I'm not sure if I can use it as a project.
Sure. Just send me if you are not confident. Yes. Also for the next class gonna be Thursday, because next Tuesday will be a holiday, and the next class is supposed to be a workshop. Okay, but workshop means you guys working and I'll be here to help out. That's the option 1. Option 2 is I can teach web scraping. So it depends which one do you guys want. Do you guys prefer web scraping?
Yeah.
Okay, that means you don't have much help for the presentations. Okay, just send me emails if you have problem, and I'll teach web scraping next class. Okay, thanks a lot. Thank you.